This video is a quick guide on the LINQ Average method. In mathematics, the average, or arithmetic mean, is a fundamental concept. It's simply the sum of a group of numbers divided by the count of those numbers. It gives us a central value, a snapshot of the middle of a dataset. Why is this useful? In everyday life, we use averages to understand trends and comparisons, like the average temperature of a city, the average income in a profession, or even the average score in a sports game. In programming, particularly in data analysis, calculating averages is just as crucial. And that's where the average method in LINQ becomes a game changer. It simplifies the computation of averages from various data types, from simple arrays to complex collections. So, let's dive in and see how average makes our coding life easier and more efficient. Average method has 20 different overloads, but these can actually be summarized into two main categories, which cater to different types of data sources. The first category is the following. This version is used when your sequence directly contains the numeric values you intend to average, such as a list of integers or floating point numbers. You can call it simply by appending average to your sequence, and it will do the job neatly and efficiently. The second category expands on this by using a lambda expression. This is particularly powerful when you are dealing with a collection of objects, and you need to average a specific numeric property of these objects. Here, the expression is a lambda function that selects the numeric value from each object that you are interested in averaging. For instance, if you have a list of strings and you wish to find the average length of these strings, you would use this version of the method with a lambda expression to extract the length of each string. Average method returns a numeric result, by default a double result, but you don't have to use double. You can use other numeric data types, such as integer, decimal, etc. But it's recommended to use double to store the result of average method. The reason for this is that the average of a set of integers or other numeric types could be a floating point number, and double is capable of holding the resulting precision without truncation. For instance, the average of the integers 1 and 2 is 1.5, which cannot be represented exactly as an integer. Now that we have laid the groundwork, let's explore how we can apply these methods in practical coding scenarios. Let's start with the basics. Here, we have an array of integers. We call average on this array, and it calculates the average value, which in this case would be 6. This is a straightforward use of the first overload. The result could be stored in a variable of type double, but also in any other data type. As mentioned before, double is the best one to get the correct number in case we have floating point number. Let's explore another example. In this intermediate example, we have a list of strings representing different types of fruit. Each fruit name has a length, and we might be curious about the average length of the names in our list. To find this, we use the average method with a lambda expression, that takes each word and returns its length. The average method then computes the mean of these lengths. It's a neat way to apply the method to a non-numeric data type by extracting a numeric property, in this case, the length of a string. For a more complex scenario, let's look at XML data representing products and prices. We can use LINQ to XML to query the elements and then apply the average method with a lambda expression to calculate the average price. The prices in the XML are attributes, not elements or values inside elements. But we can also use the method to calculate the data of the XML file, no matter how it is structured there. It illustrates how LINQ can work seamlessly with different data structures. In our advanced example, we are using a data table filled with price data. By converting it to an enumerable with as enumerable, and then applying a lambda to the average method, we calculate the average price directly from the data table. This highlights the versatility of LINQ when dealing with different data sources. I used only the average method in the examples before without using any other methods or clauses. But like any other LINQ method, we can use it with other methods and clauses, depending on our requirements. Please make sure while using this method, that the sequence is not empty, else an invalid operation exception will be thrown. In this guide, we have navigated through the simplicity and power of the LINQ Average method. We have seen how it streamlines the process of calculating averages across different data types. Whether you are working with numeric arrays, extracting values from strings, or querying complex data like XML and data tables. The versatility of the average method with its various overloads allows for broad applicability in real-world projects. Whether you are analyzing data in financial systems, building features for e-commerce platforms, or developing educational software, understanding and utilizing the average method can enhance the way you process and interpret data. As you continue to work on your projects, I encourage you to apply the average method in different contexts to gain a deeper understanding of its functionality. Experimenting with these concepts firsthand is one of the best ways to solidify your knowledge and enhance your coding skills. Now, take these insights, apply them to your own code, and see just how much more efficient and expressive your data handling can be with LINQ.